Hello everyone, welcome to Physiophysics. In this particular video, we are going to solve some NEET PYQs based on dimensional analysis. Here we have first PYQ as a force defined by F equals to alpha t square plus beta t acts on a particle at a given time t. The factor which is dimensionless if alpha and beta are constants is, here we are given four options and we have to find which of the following is dimensionless. From the principle of homogeneity, we can say that dimension of alpha t square will be equals to f and dimension of beta t will be also equals to f, which is our force. So the division of both will be dimensionless. Therefore, alpha t square divided by beta t will be dimensionless. Okay. So from here time will be cancelled. Therefore, alpha t divided by beta will be a dimensionless factor. So from the option we can say that option B will be the correct option. Our second PYQ is the E and G respectively denote energy and gravitational constant, then E by G has dimension of. As we know from our previous lectures, the dimension of energy can be written as m1 L2 T minus 2, while dimension of gravitational constant is m minus 1 L3 T minus 2. So the ratio of E upon G will have dimension as m1 L2 T minus 2 divided by m minus 1 L3 T minus 2. Here T minus 2 will be cancelled and this m minus 1 will go upward, so it will be m1 plus 1, so it is 2, and this 3 will go upward and it will be minus 3, so L power minus 1. So m2 L minus 1 T power 0. So option B is again correct. Whenever you are solving NEET PYQs, remember to solve the question under 1 minute because you have to attempt 180 questions in 200 minutes. So average time per question is just 1 minute. So we have to solve whole paper with good accuracy. Then each of the questions should be solved under 1 minute. Right? Now let us come to the question. If force F, acceleration A and time t are chosen as the fundamental physical quantities, then find the dimensions of the energy. So dimensions of energy should be in terms of force, acceleration and time. Suppose force has power x, acceleration has power y and time has power z. So dimension of energy can be written as m1 L2 t minus 2. Dimension of force will be written as mx Lx t power minus 2x. I have directly added power to the dimension of the force. Now the dimension of acceleration we have L1 t minus 2, so it can be written as Ly t minus 2y, and we have time power z. So mx into Lx plus y t power minus 2x minus 2y plus z. So here we have m1 L2 t minus 2. So m power x, and here we have m power 1, so x will be equals to 1. Here we have x plus 1, y equals to 1, x plus y equals to 2. Therefore y will be equals to 1 from here, and minus 2x minus 2y plus z equals to minus 2. So value of x and y we have 1, so minus 2 plus z will be equals to minus 2. Minus 2 say minus 2 cut, therefore z equals to 2. So our correct option will be option C, which is f a t power 2. Our fourth question is Planck's constant h, speed of light in vacuum c, and Newton's gravitational constant g are three fundamental constants. Which of the following combination of these has the dimension of length? So length should be in terms of Planck's constant h, light speed c, and gravitational constant g. Suppose h has power x, c has power y, and g has power z. So L1 should be equals to, now Planck's constant has a dimension of m1 L2 t minus 1. It can be written as mx L2x t minus x. Dimension of speed of light is L1 t minus 1, so it can be written as Ly t minus y, and dimension of gravitational constant is m minus 1 L3 t minus 2. So it can be written as m minus z L3z t minus 2z. So on the right hand side we will have mx minus z L2x plus y plus 3z t power minus x minus y minus 2z. So and on the left hand side we have L1. So from here we have x minus z equals to 0. Therefore x should be equals to z. 2x plus y plus 3z equals to 1. And here we have minus x minus y minus 2z equals to again 0. So from here we can see that power of x and z should be 1. So from this we can eliminate these two options C, in which h has power 1 and g has power minus 1, which is under the root, and this is also will be incorrect, right? And if we put 2x plus y z equals to x, so 3x will be equals to 1, so y plus 5x equals to 1, and here we will have minus x, so minus x minus y and minus 2x will be equals to 0, so y will be equals to minus 6x. So the power of y will be minus 3 power of x. So from option A and B we can see that option A will be on the correct. Our next PYQ is, if force F, velocity V and time T are taken as the fundamental units, then dimension of mass R. Now pause this video and solve this question and see which of the following is correct, right? So let me solve this question. So we want to have mass as the fundamental quantity, force F, velocity V and time T. Suppose force has power x, velocity has power y and time has power z. So m1 should be equals to dimension of force, we remember, as m1 L1 t minus 2 power x. Velocity has power L1 t minus 1 has power y and t power z. So m1 can be written as mx Lx t minus 2x Ly t minus y and t power z. Mx Lx plus y t minus 2x minus y plus z m1. So x should be equals to 1. Here x plus y equals to 0, so y will be equals to minus x, which is equals to minus 1. Minus 2x minus y plus z equals to 0. Therefore z equals to 2x plus y. So it is equals to 2x is 2 into 1 minus 1, which is again 1. So force power 1, velocity power minus 1 and time power 1. So option D will be the correct. Our next question is, the damping force on an oscillator is directly proportional to the velocity. The units of the constant of proportionality will be. So here we have, so here we are given damping force, which is one kind of force. The dimension of force will be also m1 L1 t minus 2, which is directly proportional to V. So we can write it as F equals to K into V. So dimension of force is m1 L1 t minus 2, here k, and we have velocity as L1 t minus 1. So k will be equals to m1 L1 t minus 2 divided by L1 t minus 1. So L1 L1 cancel and t minus 1 will go upward and it will give m1 t minus 1. So the unit for this dimension will be kilogram second inverse. So from here we can say that option C will be the correct answer. So the next question is, the velocity v of a particle at time t is given by v equals to at divided plus b divided by t plus c, where a, b and c are constants. The dimension of a, b and c are. This question we have solved in the earlier video, from where we can say that dimension of V and ET should be same. So A into T will be equals to dimension of V, which is L1 T minus 1. So dimension of A will be equals to L1 T minus 2. Dimensions of C will be equals to time, which is T1, and dimension of B divided by T will be equals to L1 T minus 1. Therefore dimension of B will be equals to just L1. So A has dimension L1 T minus 1, 2. So it is L1 T minus 2, and B has dimension L1 and C has dimension T1. So option B will be the correct. Next question is dimension of resistance in electrical circuit in terms of dimensions of mass, length L, empty and current I would be. As we know, resistance is given as V by I. V is potential difference, which is work done per unit charge. It can be written as W divided by Q into I. Again, charge is made up of I into T, so it can be written as W I square into T. Now, as we know, work has dimension of M1, L2, T minus 2. I is the current, which is fundamental quantity, so it can be written as A2, and time has dimension T1. So M1, L2, this T1 will go upward and it will be minus, so it will can be written as T minus 3 and into A power minus 2. So the dimension of resistance will be M1, L2, T minus 3, A minus 2. Option C will be the correct option.